Hi, I'm Tom Scott. I'm a professor at the University of Bristol and director of the university spin-out company ImiTec that makes innovative radiation mapping solutions. And today I'm going to be showing you the vehicle RadMapper technology, which we can use to map the radiation on the UK's roads. So here I am driving out of central Bristol. I'm heading to Fenswood Farm, which is the university's rural facility where we do nuclear robotics. My RadMap is working, and in doing so the heads-up display is telling me how good my GPS fix is. So for example, at the moment I have something like 9 satellites locked onto the system, so I've got very good positional information. I've got my counts per second, which tells me how radioactive it is, and the final thing is it tells me how good my mobile phone signal is. So the unit I'm using is actually broadcasting data through the mobile phone network, and it's sending it to a secure server. So someone who's at a central location or has access to the secure server can see what my vehicle VRIAS unit is measuring at any particular point in space and time, and it can do that for multiple units, lots of units in fact. So that data that is sent through the mobile network is encrypted, and it's good to have data that's repeatedly measured over the same stretch of road or the same area, so that we can actually compare data from one map to another and see if there's any measurable change. And the advantage of having a buffering capability in terms of the data is that I never lose any data. I store it on board onto a USB stick, but I also broadcast that data such that if something happened to me, something happened to the vehicle or the USB card, there's still a memory recording of all of the data on a secure server at a central location. This is really very useful. So we can use this RadMapper unit in a car, but equally we can put it onto any outdoors robot, any area that's not GPS denied, and we can use the same capabilities such that the robot can be doing an automated survey, for example on a beach or around a certain nuclear compound, and in real time the data it's recording is sent straight into the secure server, and so the person in the comm center has the data in real time, and that's really very useful. And they have the full data, the full spectral data in real time. The delay is less than a second in fact. For safety, I've pulled over and now I've got my iPad, and I can actually log into the ImiTec's server, and I can see the data that I've just been recording in the car. I can see that with a satellite underlay, and in fact I can choose to follow the track that I've driven and see slight variations in the background radiation levels, and it will show any localized anomalies which are barely above background. And I can do that switching between the satellite underlay to a grayscale map, and also if I want to I can turn on topography as well, and by using this interactive user interface via the web, I can start to correlate any radiation hotspots with specific buildings or topographical features, which helps me to interpret the data. I can also look at my time series data through my trip, which tells me how the average radiation level has varied through the course of my mapping exercise, and again that's very useful for situational awareness. So that's the vehicle VRIAS unit, the vehicle RadMapper developed by ImiTec Limited. It's a really very useful bit of kit, and it gives us an enhanced situational awareness tool in terms of nuclear emergencies, when you would need to understand the spread of radiation and its spectral fingerprint, i.e. the risk, what it's coming from, very rapidly and in real time. And that ability to transmit the data to a secure base station, to a secure server, such that anyone with a clearance can see that data in real time, is really beneficial in terms of shortening the time for decision makers to get the correct information and to, from that, make the correct decisions about what to do in an emergency.